Support for Lab Out Loud is provided by the National Science Teachers Association. Find out more at nsta.org. You're listening to the Lab Out Loud podcast, Science for the Classroom and beyond. And today we're looking at a resource from NASA that helps kids explore the Earth.
Basically, what we try to do is introduce 3 stories in the beginning of each issue. One that's kind of a local, something smaller scale that they can wrap their heads around. Then the second story is a little bit broader view, a regional look. And then we try to bring it with each issue a global view, because that's really what NASA does. We have that global perspective.
That's coming up next on Lab Out Loud. But first, I'm your co-host, Dale Basler.
And I'm Brian Bartel.
When you think about NASA, it's likely that space exploration is going to come to mind. But when you talk to Ginger Butcher, she may remind you that NASA has more to its mission than looking beyond our planet.
Working at NASA, you just say NASA. Oftentimes, kids get kind of excited about what are we gonna do? What are we gonna work on? But the other part of what is a little bit challenging is that we're in this unique place of Earth science at NASA, which isn't astronauts. It's not space shuttles. It's not stars and galaxies.
Ginger works for the NASA Goddard Space Flight Center and has been involved with Earth science missions for almost 20 years. Through those years, she has been sharing what NASA has been up to with our students by creating engaging lessons that include stories and activities.
So what we try to do is make it as hands-on as possible. I've developed some activities using Legos. I've worked with a commercial company, Little Bits, to develop a space act agreement with them so that we can put together a space kit with activities inside that can do.
Sure, we talked about that on this show. We
love Little Bits.
We had the founder of Little Bits as a guest, and actually talked about the space one for a little bit. Yes.
Yeah. So I had approached her because there was actually how that came about, and there's a real interesting activity that the folks with the SOFIA mission had put together. It's an infrared astronomy airborne mission. They actually fly these instruments on a large airplane. Right? So when I started doing Earth science to share with kids, I was trying to communicate to them how we basically sense the electromagnetic spectrum from space, and that's how we get these images. So something that's a true color image would be, something that looks similar to what we would see with our eyes, but we look at beyond the visible part of the spectrum, both in astronomy and in earth science. And what I wanted to do is I put together this little activity where they build a little engineer a satellite out of Legos. And each of the pieces of Legos kind of are representations of different types of instruments on how we break the spectrum apart, whether it's a radiometer with filters or whether it's a spectrometer with a diffraction grating. Still, there were representations of that because they were just Legos. And I really wanted to allow kids to explore and have a hands-on experience with this light we can't see. And that's what SOFIA did really well. They did this listening to light where they basically you hook up an iPod or MP3 player to an LED, and you basically play your music through the LED light. And then there's a solar panel that picks up that light and transmits it through this speaker. So you can do this wireless transmission of infrared light. And you can also do it with visible light. So you can show them that that's how data is being transmitted. You can show them that different wavelengths have different properties. The infrared will go through some fabrics and things that the visible light will get blocked. And so when I did that, I wanted to do it for a large group of kids. We do these events like the Science and Engineering Festival in DC that comes here every 2 years. And it's kind of hard with these alligator clips and LEDs. I kept putting in the IR LED backwards and burning them out. I went to pretty much every Radio Shack in a 50-mile radius of my house to buy all the LEDs.
Aw, Radio Shack.
So you killed Radio Shack.
Oh, they've got I supported them very well.
Yeah. I almost missed the fact that you don't have a local place to go and just grab things like LEDs and stuff like that.
Right.
Because that may have been one of the only places around here where we could have gotten that.
Yeah.
But you walk into a classroom and you're like, I'm from NASA and I've got Legos. I mean, that interest and engagement, check. All right.
I think I did a similar lesson in my science classes and physics classes, just wired into So I take the iPod sound and wire it into a laser pointer. Same thing. And then, but it kind of bums me out that I didn't think of switching to like an IR and different. That would have been a great idea. Why didn't I think?
And what we did, so you're familiar with all the little pieces you've got to put together. So that's when I went to Aya and I talked to her and I said, these little bits are great. Well, let's see if we can emulate that with the little bits. Yeah. And they actually invented or developed that light sensor as part of that effort, and the IR LED and a few other things in the speaker right before they came out with the synth kit. But
because mine was like he's like a resistor and a lot of tape and just a laser pointer pen that didn't cooperate all the time. It's a lot of
and it's hard to do that with a large group of kids that are just going to come in and only be at your station for a couple minutes. And then, so I soldered it all together in a black box, but that's no fun.
Yeah,
so,
exactly.
We almost did the laser, but they couldn't get the little bits couldn't get the laser past, safety check,
age level. Sure.
Yeah.
I had one of the cheesiest dad jokes for that though, because I would do that. I do a demo of that on top of the front lab table, and I had it sitting in like a lunch tray that had a lip on it, and I would take a comb and go through the laser beam and basically saw through the laser beam, and the comb had the teeth of the comb would be breaks, and it would cause like blips, and it would just make a sound as I went through there. And I do it in two different places, and I'd be like, oh, it fell down, and I had a red straw sitting in the lunch tray. I pick up, I'm like, oh, I just cut some of the laser out. I loved it. For me, it was a great joke. The kids
Dale is in his wheelhouse right now. Is this? I kind of feeling like, is this what it feels like, Dale, when we're doing a biology, chemistry themed show?
Yeah, when you start talking, Gogli bodies, I kind of gloss over. Yeah.
We got a chance to learn about another NASA resource that's being targeted to young students. Ginger is actually the editor-in-chief of EO Kids, a magazine-style online resource. The first issue of EO Kids came out in October of 2016. Issues come out bi-monthly, and a recent one in January caught our eye. It was all about urban heat islands, which is something we're really drawn to given that we're coming out of a cold Midwest winter.
Well, so cities are hot. They're a hot place to be for a number of reasons. Although even Milwaukee, Wisconsin probably doesn't feel so hot. Appleton, Wisconsin, probably not so hot either right now. But if you look at even those cities compared to the farmland that surrounds it, they're just going to be hotter. And they're going to be hotter because they have more impervious surfaces, which is all those things that people build. So roofs, sidewalks, pavement, parking lots, the big box stores too, all of it. Water doesn't get through. That's what makes it impervious.
That's Tasia Owen. She's the managing editor for EO Kids. She's also been working with the Terra mission. Terra is the flagship Earth-observing satellite that has been working for the past 17 years while observing Earth. Tasia has been helping NASA with science outreach and communication. She was also formerly a high school science teacher. It definitely shows as she explains urban heat islands.
So the ground where grass grows or corn grows or trees grow is all covered by these plants that can take on water. And water has properties that keep the air cool. It has the process of evapotranspiration. So if you go out to the countryside, the air is going to be cooler than the air in the city that's in contact with that ground. So we thought, well, this is a really good opportunity for us to be able to try and explain this pretty fascinating phenomena from a perspective that's a little bit different than, hey, kids, let's measure some temperatures in the city and let's get on a bus and measure some temperatures out of the city and let's compare them. Because, well, we're NASA and we have a really unique perspective because we've got the satellite perspective. Mm-hmm. So using infrared sensors on different satellites, we're able to actually see the heat difference between the countryside and the city. Mm-hmm. So we just kind of thought, well, this would be a really good opportunity to look at this from this perspective and explore it in kind of a different, more hands-on and engaging way, and talk about some of those different factors, scaling it up from, one local area all the way up to urban heat islands and where is the hottest place on Earth in general.
Now, is there a map where we can pull this up? I see one of the pages of this issue where it shows sort of the Midwest and East Coast in different colors, red and things like that. And you can, obviously, it looks almost identical to one of those nighttime where are the lights maps because they represent population. Is there a map that you can actually pull up to see your city, your area?
Well, you can. You can zoom in on any of them. So if you look in the issue, it's funny that you say that it looks a lot like the city lights at night because one of the activities is to compare the urban heat island map with the city lights at night map.
Oh. He just got started on this, so that wasn't prompt, fellow people. No, that's great. That's a great idea.
Opened it.
Yeah. Yeah. So so that's one of the activities that's actually in this past issue. And as far as looking at your actual city, the resolution isn't high enough where you can actually get in and look like, oh, hey, there's my neighborhood.
Yeah.
But there's also one that looks at Minneapolis, Minnesota. It's zoomed in at the completely pixelated scale.
Yeah.
And it's just the Minneapolis, St. Paul, and a little bit into Wisconsin.
When you say the resolution isn't good enough, you mean the resolution of the original image from the satellite, right?
That's not necessarily true.
So it
depends. It depends what satellite they're using the data from. So
I guess my question is, could you look at the park compared to the parking lot? Is that doable in somebody's neighborhood?
You could definitely do that in your own neighborhood. There's an activity that you can do that using an infrared thermometer yourself.
Oh, okay.
So as I'm looking through this, it kind of like reads like a magazine at points. It's like a downloadable PDF, nice color, and it's just graphically laid out well. There's obviously information and activities, and what else is there for students or teachers to access?
Basically, what we try to do is introduce 3 stories in the beginning of each issue. One that's kind of local, something smaller scale that they can wrap their heads around, introduce some of the vocabulary like impervious surfaces and such. Then the second story is a little bit a broader view, a regional look at this point where we actually just took the United States. And then we try to bring it with each issue a global view because that's really what NASA does. We have that global perspective. So not only can we look at, the differences in temperatures between the cities and roads and highways in the United States versus the farmland around it, but we can also look at the entire globe and what the temperature differences are and where's the hottest place on Earth. So that's kind of the third story. And then we try to add my favorite thing when I was a kid was a Highlights magazine that had that.
Oh yeah.
Make stuff out of old boxes and paper towel tubes and stuff. So we have a maker corner in each one of the issues. Kind of go and grab some glue gun and some household supplies and make something.
Now, is there a way to subscribe to these issues so you don't miss them? Or, you get them up to date in your inbox or something like newsfeed or?
Yes, the Earth Observatory has a
right here
listserv, and you can join that, and you'll get their updates when they come out.
Okay, we'll put a link in the show notes. It's right there. It says subscribe today. I didn't look at it.
I'm looking at the first issue, the freshwater issue, and it in a similar fashion, there's a lot of visual data that's displayed here. And I think that's one of the key features about NASA and other institutions as well. NOAA would be right up there, where I'd love to be able to have kids go into the data and make sense of it and have them, come to some of their own conclusions by what the data is telling them. And is that part of what you were thinking here?
Well, we do provide some data investigations and data viz because a lot of what we do here is visualizing data. So either doing a color scale or a color map visualization. Our next issue is going to have, or next issue, but we're going to do an animation flip book visualization.
Oh, cool.
And so we do want them to engage with the data, but it's a little bit different in kind of that pen and paper PDF form.
Yeah.
And we hope in the future that there are some tools out there that allow kids to download and look at and come to their own conclusions with different data sets. The NASA Earth Observations, NEO, which is one of the ones put together by Earth Observatory. We're in the process of trying to make that a little more user-friendly and having some activities built around that. But there are definitely some places that kids can go and actually look at the real data and pick an area and pick what data set they want to look at. So yes, we want to kind of move in that direction.
When you build your resources, who do you picture your target audience? It says age 9 to 14. So are you writing everything to that audience then? Everything we can find at that site is sort of.
We're trying to, for the EO kids, we find that by the time they get to high school, they should really be able to dig into the Real Earth Observatory website for the content. It's written, and if too much younger, we're having challenges with some vocabulary and stuff. So we kind of looked at what are some of the other magazines out on the market for that age group. And there seems to be kind of this very young, kind of like K through 3, 5 to, 7-year-olds. And then that middle area where like Sports Illustrated for kids or National Geographic for kids. That's kind of why we kind of placed it at that place, at that area. But I think it's open and enjoyable to people of all ages, at least from what we've been getting out for feedback from folks.
Is there an option to get a printed version of it, or do you print it yourself?
Yeah, you got to print it yourself. NASA really doesn't have a mechanism to print and mail subscriptions to print copies. We may in the future have some print copies that we would take with us to conferences. NASA has a presence at NSTA and a few.
Well, okay, that makes sense. And they are laid out so that you can print them and make them into a magazine quite easily. So that's kind of neat.
So how do you pick your topics, and can you tell us a little bit about what's to come?
Tasia, do you want to take one?
I'll field that one. So we choose our topics based on a lot of different factors. Sometimes it's because of different science that's just coming out. So if there's going to be a really cool research paper that's going to be published in one of the top research journals, and we know that it's going to be timely, we'll choose something with that. Otherwise, we look at current events that are going on as well, and also try and pick something that would be seasonal or timely based on the time of year. So we did the freshwater issue because of the science and the big news at the time. The current events had a lot to do with drought and the receding snowpack in the Sierra Nevadas. And what that would mean for California. So we thought, well, this would be a really good opportunity to talk about just what is the impact of freshwater on Earth, and how does NASA measure that? So then moving forward, there was a interesting article that had come out written by a scientist, Lahuri Benua, about his work with urban heat islands. And since I work closely with him, it was a really great opportunity to be able to actually include some of his real modeling data research in something that is just an interesting phenomena to talk about. And so that doesn't have to do with any time of the season or anything, or even current events, except that it's cool and it is current. It's current science. But then our next subject that we'll be going into is landslides, which I live out in Portland, Oregon, and we have been having a lot of landslides this time of year. We've been getting historic amounts of rain. There's been roads shut down almost every week because of a landslide for the last couple of weeks. It's a real threat out here. And this time of year, it's one of the main issues that we deal with. And especially since this year was such a heavy rain and heavy snowpack year for a lot of the western portion of the country, the landslide factor is running high. So again, it's another current event, and trying to be timed to be seasonal along with everything that's going on. And then
it's definitely going to bring in, there's places where landslides aren't occurring at all. So it gives students a chance to be empathetic of people in different locations.
Yeah. And what actually you'll find out is that landslides can occur actually anywhere. And that it's not just heavy rains that causes it. There are definitely places that are predisposed because of the steep slopes and the amount of rain that they get. But there's other factors that can lead to landslides as well that does not have to rely on any of those forces. There's actually a map that'll be in it that shows the different landslides throughout the globe for the last 10 years. And you'll see that it's basically in every country and in every continent. And I think that the statistic is something like there's been a landslide in every single one of the United States at some point. So
now, thinking about current events, do you have an upcoming episode about man-made dams and when they fail? Because I'm sure you can get some great footage about what is before and after a dam, of course, with the aerial footage and whatnot, and how it changes the landscape.
Yeah, I wish that maybe we'd held off on the freshwater issue for a little while longer, because that would have been very timely for right now.
Oh, yeah.
But yeah, who knows? I do know that the one that we're looking at doing after landslides is actually about spring and basically the greening up of our planet.
So when's that supposed to come out? Is that April?
That would be May. As long as timing all works out and everybody stays mostly healthy.
What about video? Have you given that any thought? I think about my kids in school almost daily watch CNN student news, and it's an easy thing, I think, for teachers to kind of push out current events to the kids. Do you have anything like that, or have you given that any thought?
Ginger, you want to field that one?
Sure. Basically, we started out with this PDF concept because it was a kind of a magazine format, weekly reader, highlights, however you want to call it, to share with kids. We often have a lot of scientists that go out into classrooms, and it's nice to have something that's digestible for that audience and is inviting. And we also are looking at basically making this into web pages. The Earth Observatory is looking at, they're in the process of doing a revamp on their design. So we'll probably have some web page components. And it would be nice to do that, because then we could include some, contextual links. We can include stuff like, links to the videos that are on our scientific visualization studio that puts out some really fabulous visualizations and videos. We haven't looked at putting together specific videos for this audience, like what you said with like kind of the CNN piece, because that's not really we're not a media house, I guess.
Okay.
So we're trying to emulate what Earth Observatory offers to the general public audience, and so we're trying to basically repurpose some of that content for a younger group. But it's still pretty much we're a group of science writers and scientists and educators, not really a media house.
Well, I kind of like the PDF in a couple ways. And first of all, the way you mentioned, like the highlights kind of a setup, I absolutely go back to those days and think that makes me think of the dentist office, because that's always where we could
Goofus
digest.
and Galant, wasn't it?
Yeah.
We could always digest the highlights right before we got our teeth cleaned, but that was where I saw it the most. In any case, I think about how the workflow of students might happen now, where we have one-to-one devices, maybe a Chromebook or whatnot, and this could easily be passed out via an LMS like Google Classroom or something like that, where kids could access it. They could access the web link and get to it as well. I think there's a lot of potential in that. And also, it's pretty friendly for our non-digital times in the classroom, where a teacher could print out not necessarily the whole issue, but maybe a couple pages or the data viz activities or things like that.
Right, and we try to make the data viz and the DIY science, that you can print them out in black and white and still get the gist of it. We didn't hit it so much with the urban heat islands because we have the red squares that they're counting. But even if you print it in black and white, you can still depict which are the darker colors. But that's important to be able to have access, that they can have several copies of it to print out.
Before we let you go, this is NASA. All of this is funded by the U.S. government, correct?
Your tax dollars at work.
Yeah, and I think if teachers are listening and saying, well, I really like this, I want to make sure that this is continued, is there something that teachers, citizens should be doing to demonstrate their support for projects like this?
Well, we do have a feedback link on the site, and I capture all of those and share those with our stakeholders. So that feedback is really important. I mean, we get people who say they've shared it with their grandkids and they love it, or this has worked great for my even an undergrad class, that they kind of use that for a kind of a teaching activity. There's a variety of uses, and so when we hear that there's a need, that we're filling that need, and they're writing us about it, that helps us continue to make our case to, continue doing this work.
Excellent.
Well, Ginger, Tassia, thank you so much for your time. We look forward to your future issues.
Thank you.
Thank you very much.
For links and other information related to this episode, visit laboutloud.com. You can send us your questions and comments at laboutloud.com/contact.
If you enjoyed the show, make sure you've subscribed on iTunes, Google Play Music, Stitcher, or your favorite podcasting platform. And if you really enjoyed it, consider leaving us a rating or a review. Your feedback helps others find our show.
Until next time, I'm Dale Basler.
And I'm Brian Bartell.